Hi, my name is Jordan Calvert and I'm an engineer at NI. Today I'm going to show you how to compile LabVIEW models for use in VeriStand. First, let's take a look at the software requirements. We need LabVIEW matching the same year version and bitness as VeriStand. So if we're using VeriStand 2025, we need to build our LabVIEW code in LabVIEW 64-bit 2025. We also need the LabVIEW real-time module and the VeriStand model generation support for LabVIEW package. That is included in the VeriStand installer. And lastly, if we're going to be building for an NI Linux real-time target, we need the C++ development tools for NI Linux real-time 2017. When a LabVIEW VI is compiled as a model and then run in VeriStand, it runs as a single step in the VeriStand model loop. Since VeriStand is doing the looping, the VI itself should not contain any while loops around your model logic. You also shouldn't use any queues or front panel object property nodes in your code, since those won't work properly in the compiled model. You also need to make sure that the model will execute fast enough so it doesn't slow down the rest of the VeriStand engine. Supported data types for your model I/O include numerics, booleans, fixed size arrays of numerics or booleans, or clusters containing any combination of the above. In my application, I have a controller PID model that I need to test, and I'm going to create a plant model to connect to that PID loop. Here I have my plant model code. If I look at the front panel of this model, you can see the controls and indicators that will act as the model inputs, outputs, and parameters. These controls and indicators must be connected to the VI connector pane. If a terminal and the connector pane is marked as required, then that control will be a model import. And if it is marked as recommended, it will be treated by VeriStand as a model parameter. Also want to point out that the VI name should not contain any spaces. And now that the VI is complete, I can compile it into a model. I'll do that by going to Tools, NI VeriStand, Generate Model from VI. In this dialog, I can select what target OS I will run the model on. So whether I want to build it for Windows or for Linux real-time. In this scenario, I will select Linux. And by default, it will save the model to the same folder that the VI is saved in. Let's hit Build and begin the model compilation. Since I selected to build for Linux, this process will use the C++ development tools, which is the cross compiler for NI Linux real-time. Now the compilation is done. Let's hit Finish. And then if we look at the folder that contains the model output, you can see the plant model.lvmodel.so is the file that we just compiled. If I had selected Windows, the output of the model would look like this with the .lvmodel extension. And here you can also see my PID model that I've already built. I've created a VeriStand project, and I've already imported my PID model, but let's add the plant model. To do that, I will go to the software palette, simulation model, and drop a new simulation model node onto my mapping diagram. I will then browse to the location of my .lvmodel.so file and select that. Now if I drag down this node, I can see my model import and model output. I can also import my parameters by selecting the Import Parameters button, and then I see the 3 parameters that were in that cluster on my VI front panel. Because those parameters were in a cluster, VeriStand will import them as a folder, which is useful if you have a model that has a large number of parameters. You can use clusters to organize those parameters into useful groupings. Let's hit OK. And now I need to connect my model to the rest of my project. Now that that's connected, I will save and deploy to my real-time target. While that's deploying, let's take a look at my VeriStand screen. This is a user interface I created so that I can verify that the model is running correctly. Here you can see when I change my set point, the PID model starts adjusting its output variable, and you can see the response from the plant model going towards the set point. And leveling off once it approaches the set point. Thanks for watching. Hope you learned a lot, and if you want to learn more about VeriStand, you can visit our website at www.ni.com/VeriStand, where you can access VeriStand documentation, including documentation about building LabVIEW models, and access the VeriStand download. Thanks and have a great day.